I think we are already live via streaming. I would like to first of all thank you all for being here today. It's quite amazing the large audience that we got. Hopefully it's the same via streaming. And also I would like to thank all the alumni that have come and will talk later on in the open day, and also all the members of the department who have contributed to the presentation, and Maria, who has just left to get some water, who has helped me putting together all the logistics. So when I started to think about how to prepare this open day, I posed to myself this question, right? You know that nowadays we are facing a new revolution by the artificial intelligences. And I was thinking about the future of jobs in the aerospace industry. And so I asked to this bot, which I guess you know, and it threw me the following the following answers. It seems that jobs that require creativity, critical thinking, human interaction will remain in the future, including aerospace engineers. I would say not all of them, but it seems like we're in the good direction. Of course, if all those jobs that are highly repetitive, routine, and involve systematic amount of data might be substituted by intelligence, artificial intelligence, or tools. The aerospace industry will continue to evolve and adapt to the changing landscape as we've done throughout the last century. But of course, we need to change the way we are facing engineering, aerospace engineering. I was not very convinced about the first answer because we are aerospace engineers and we know that some of the jobs we are doing probably will be substituted by machines. So I keep asking, do you really think all the aerospace engineers will remain in the future? Just with a bachelor and a master? Or do you think we need additional background, additional training? And well, the chat provided me this answer. We will continue to play an important role. That's good news. That is clear. And in terms of education, it seems that pursuing a PhD might be a good direction to get creativity, critical thinking, and eventually, have jobs in the future. So this is the answer I was looking for. So it seems that pursuing a PhD might be a good option to complement bachelor and master studies in aerospace engineering and other fields. Now, why to pursue a PhD in aerospace engineering? I continue asking the chat. And it seems that it provides skills in problem solving, critical thinking, data analysis, so advanced knowledge and skills, which is good. It also seems that it provides innovation or capabilities to innovate, which is important, creativity. It offers the possibility to grow personally. So those three are intellectual assets, which we all are looking for. But on top of that, and this was not the fourth answer, this was the first answer provided by the chat, it seems that will be a highly specialized and well-paying position in the field. So it seems that we, or a PhD, would get a good reward, which was not the case in the past, but it seems it's going to be in the future. All in all, the chat, it's not me, thinks that pursuing a PhD in aerospace engineering can lead to a fulfilling and rewarding career. We'll see that today, while making a valuable contribution beyond the state of the art, creating, innovating, and intellectually speaking, being satisfied. All in all, by pursuing a PhD, and this is my opinion, you could be differential, and you need to be differential from a technical perspective. You need to be more and more creative, but do not forget the humanities. Keep asking questions to yourself. Keep putting the human in the center. By putting the human in the center, by being exposed to many dimensions, writing, speaking, different scientific cultures, we will be then creative, like surfing the state of the art, the frontiers of knowledge, and by that, we will be in the end differential to tackle any problem in the future. So this is the direction I think is the direction to go. Now, what is in our program, the mission? Well, we provide specific training on our space science and technology, from the theoretical fundamentals to numerical principles, moving to experimental, and we have very nice experimental facilities in the department, to make a multidisciplinary, international, intersectoral career in a way that our PhD students can in the end find opportunities where to follow a scientific career, both at research centers and also universities. And we have some examples, some people working at MIT, Princeton, Onera, INTA. Of course, also this is not working quite well, I would say. To follow an R&D, if you want to be an R&D, research and development engineer, follow a career in here is a good option. And we have many people working Airbus, Deimos as an example, and you will see them today. And finally, and this is also important, to create your own startup. And for that, of course, you need to have knowledge, and you need to be innovative, you need to be creative. A PhD offers you the possibility to follow this path, and we will see also 2 examples today. So, the agenda. This was the welcome, so welcome to all. I will start by describing the program myself, hopefully quick. And I already did the welcome. It was not the chat, it was me, I would say, but the chat helped me. Then the members of the department, those leading the different research lines, will tell you or will provide you a helicopter view of what we are doing and some of the opportunities for doing a PhD that are open now or might be open in the near future. And I don't think the chat could ever do this, maybe in the future, but of course humans are in the center here. And after that, we will have 5 very short presentations showing or telling 5 stories about how did they ended up in their current positions, and eventually also now offering postdoctoral or PhD opportunities for you. And at the end, we'll have a lunch break, and I also asked the chat if it wanted to join us, but unfortunately, it is not going to make it, okay? So, well, I mean, this was a bit philosophical because a PhD is doctor in philosophy, and I think I was talking about humanities and philosophical question, and this is important in the end. Just a bit of joking, but I think it's something that is a hot topic today, and we need to take it seriously as it is a quite powerful tool. Now, about the program. It is divided into 2 main areas, space and aeronautics. We have 8 research lines, 4 on aeronautics, including structures, material, aerodynamics, experimental and computational aerodynamics, propulsion systems, then all the design and manufacturing of the vehicle, and finally the operation of the aircraft. So we, of course, are touching the classical fields of aeronautical engineering. There might be, of course, others. When it comes to space, we have propulsion, we have all the different systems, we have astrodynamics, including space debris, which is a hot topic, also space tethers. And we have also control, which is a mix between space and aeronautics, which is also a quite interesting topic today, linked to CubeSats, UAVs, and automatic vehicles. The researchers will be explaining a bit more in detail the different research lines, but I wanted to provide you this picture. Our PhD students, we are devoted to provide training for our PhD students, and you, some of you are here, are the core of the program, right? We have 53 of different nationalities, and this is good because we want to be international. We are a bit biased towards males, and this is something we want to somehow bridge to some extent. So female engineers or mathematicians that want to pursue a PhD are quite welcome, and we are really looking forward to have more women in our program. And also when it comes to sector, we have many academic PhDs, but more and more these PhDs, I mean the industry, are willing to have employees pursuing also a PhD, and this, I think we are moving in a good direction, in the right direction, in terms of industrial and also cooperation with institutions such as ESA, INTA, and other research centers. This year we had our first 3 students graduated from the program at the end of the year, and one of the ambitions is to build a network. Networks are quite important towards the future, so having these 3 students or our 5 panelists that are not graduated from our program but from other programs but supervised by ourselves is important, because they're going to provide you a first contact with some jobs, some opportunities, experiences, and I think this is going to be always important. We are working hard in creating a portfolio of activities for each of you, those currently doing the PhD, but also those graduated, in which you have your picture when you started the PhD, so you were young and dynamic and healthy, and here you have your final result, the PhD, which can be downloaded. We also include projects in which you have participated, research stays, which somehow is depicting your international connectivity, and videos. We are recording your presentations so that anyone can access to the portfolio and see how good you present, how interesting your topic is. And this has worked, for instance, for a PhD student of myself. I wanted to send him to with a professor, and he checked this, and well, he accepted the PhD student. So in the future can be also interesting as a portfolio for you. Supervisors. We have here we have some of the supervisors. This is an important figure because they are they are leading researchers in the aerospace industry in Europe or all over the world, and you have the research portfolio of each of them, the group they belong to, and I will tell about practicalities at the end. But the very first thing you need to do to pursue a PhD is to find a supervisor. Find the topic you are passionate for, you feel passion for, high level, reach a potential supervisor, a potential team, and then try to polish the topic and see if you can get some funding and so on and so forth. So supervisors are also quite important for us, and we are looking forward to have more supervisors, also more female supervisors from other departments, companies, institutions, etc. This seems to only work if I point to it. We are working, and these supervisors indeed are principal investigators of very relevant projects at European level, including starting grants of the ERC, European projects we are coordinating, Marie Curie networks, national, regional projects. You have all the portfolio here, but many of our PhD students are actually working together with international consortiums in projects or together with the industry, which I think is a quite nice asset for us. What are the activities we typically program, and if you want to pursue a PhD, you would need to follow? First of all, seminars. We think that being exposed and connected to researchers of different fields, being exposed to orthogonal ideas, is very important to really foster innovation, foster creativity. If you are always focused on your topic, you don't find the spot to really think out of the box. And here's where you might find opportunities and be meeting them. All the talks are recorded if you cannot attend physically. And well, we are having 2 seminars soon from Rafael Vázquez and in April, next week. And also Sarah Jimenez will come. This is to be confirmed in May to give a seminar. So these are the upcoming seminars, and we are making also an effort to broadcast all this information by Twitter or via Twitter and LinkedIn. So please follow us if you are not doing so. Other activities, and this is probably the most important activity, is the PhD doctoral meeting we organize every year, in which you, PhD students, you are the ones to present your work. And here I think it's important to be exposed to your peers, to your colleagues, understand what they are doing, how they are tackling the problem, and really starting to create a network of collaborations between you. All right? Again, all the videos are recorded, and we have organized this year the meeting. We split it into 4 sessions during the morning, in which you guys, you folks, will be presenting your activities and discussing with the supervisors, having coffees, lunch as today, and so on and so forth. Other very important activity for us is to do a research stay. I would not understand a PhD without traveling abroad, even my life, I would say, being exposed to a different environment, international environment, other people, other ways of working. This is quite rich if you've done an Erasmus, for instance. In the PhD, you can also do that. And we have suffered from the COVID, which imposed us a lot of restrictions. But now, more and more, our students are traveling, are visiting ESA, JAXA, universities in the US, universities in Europe, and this is a quite rewarding experience if you start a PhD. Other things that we are organizing are courses, specific courses and workshops. This is difficult because the topics are quite broad and quite different from each other. We try to organize specific courses every year on different topics. This year we are organizing a course on aeroacoustics that might be suitable to some of you. Some others might find it a bit out of scope. But in any case, it's a 12, 16 hours course on this topic, and we will try to program courses from the different disciplines every year. And another thing we have started, Mario had the idea, and we're having it next week on Tuesday, is an exchange workshop to provide you with a hands-on workshop of 3-4 hours on a transversal topic that might be of interest. In this case, we are going to work with ParaView, software to visualize information, fluid fields, that might be relevant for some of you, and of course a quite relevant thing. You have the information in the web should you want to take a look at it. Last but not least, because we are somehow surfing the frontiers of knowledge, we have to disseminate and communicate our results, and we are expecting that you would be publishing at least one journal, good quality journal paper, eventually more than that. Also attend to conferences. For instance, some of my students are traveling to Vienna next week for a conference, and this is another thing we are doing. Okay. As for practical information, and I finish, this is my last slide. If you are thinking on doing a PhD, which if you are here, you should be thinking, you need a bachelor and a master. Well, you need a bachelor of 240 credits and at least 60 credits of a master degree to enroll in the program. We are looking for anyone with intellectual curiosity, with this feeling of scientific feeling of the things, critical thinking, and we are looking for anyone, in particular in science, mathematics, applied physics, and engineering in general. Of course, aerospace engineering is our main target, but not only that. More and more we are becoming multidisciplinary. So people from computer science, data science, electrical engineering, electronics, I don't know, plasma physics, mathematics would be of course of interest. So do not hesitate, please, to touch base with us if you are thinking on doing a PhD. In terms of admission, I was already mentioning that you first of all need to find the topic you feel passion for, and the supervisor with whom you feel there is a feeling, right? Because you're going to be working for 4 years with him, her, in a group. This is the most important thing. Then you will need to find funding. You will need, because you're going to get paid. Of course, this is a job, right? A job that comes together with training. It might be provided with contracts associated to projects. Many of our PhD have contracts associated to projects, but we can also get a scholarship, right? The scholarship typically needs the support of the supervisor. That's why you need, first of all, to get in touch with the supervisor. If she thinks you have the potentiality to go for La Caixa or these national scholarships or even the regional ones, she will tell you, okay? And you will be preparing a proposal for that. Then you will fill the paperwork, and I particularly, or we will be helping you. So do not worry about that. And the same applies if you're in a company, okay? If you're in a company, maybe you need, first of all, to talk to your supervisor in the company, but then the process is exactly the same. The funding, here, probably you're already working, you're already getting a salary, you would need to arrange some reduction in your duties to allocate that time into the PhD, maybe 25, 30%, the more the better. The more aligned the topic is with your work, the better, but same applies, okay? And the requirements in the end, as I was saying, one paper, participate in doctoral meetings, present at least once in a conference. If you want to have the international mention, which is not a must, right, but we highly recommend it, you have to go abroad for 3 months, attend seminars as much as possible. All the courses are optional. We have also soft skills, but again, the more you are exposed to the different training activities, the better in the future for you. You will retire probably with 70, 75 years old, so get trained and dedicate your time to really grow. No, because many people is like in 23 years, I want to work. Yes, okay, go and work. But be aware of how the future would look like. Okay, so I don't know how I'm doing with time, but in any case, now it's time for the different researchers to come up here and provide a 3 minutes, please, overview of the research activities. I think we start with Marco. So please, Marco, you can directly talk to the.
Sure.
I can maybe, or you can use this and.
Yeah, sure. So I'm Marco Raiola. I'm a representative for the Experimental Aerodynamic and Propulsion Lab. In this group, we are driving several research lines. The first one that I'm showing you here is the development of non-intrusive measurement techniques, essentially optical techniques. For example, the use of infrared thermography for both thermal measurements and heat flow measurements. And what you see here in this slide, which are essentially particle image velocimetry measurements, which essentially use both lasers and cameras to visualize tracer particles in a flow in order to track their displacement. And for example, one can reconstruct the flow, such as you see in this video of a swirling jet, in which we are showing the three-dimensional flow field. This research line is currently being funded through the Next Flow project, which is an ERC starting grant project led by Stefano Discetti. Another line that we are following is essentially the use of machine learning for flow control. This comprises essentially 2 sublines, which is the flow sensing, essentially the use of few sensors to essentially estimate what happens in the flow. Here you have an example, for example, to estimate what happens in the flow, starting from measurements from a wall, for example, on top of a wing, and to know what happens in the flow. And this is especially useful for active flow control, essentially using this information to control the flow. And this is something which is essentially inspired by nature, in which one can essentially try to control the flow by trial and error. And essentially the idea here is to use, for example, some machine learning technique, such as reinforcement learning, to control the flow. And here you have a video of the control of the Kármán wake in the wake of a cylinder. The last line which I want to present you is aeroacoustics in turbulent jets, which is a very important problem nowadays. Essentially, the idea is to study and try to control the noise emission out of a turbulent jet. Here you see a simulation of the jet and the noise, the pressure wave being propagated. And currently we are running some experiments in our anechoic jet facility, in which we are combining several techniques, for example, particle image velocimetry with microphone and hot wire measurements, in order to reconstruct the flow and reconstruct the sound emission. And apart from that, what we are doing also is to run a research line into beamforming for the identification of noise sources, which essentially is aimed at using microphone array to spot noise sources, such as you can see in this picture of the noise from an aircraft. As for positions that are going to be opened in the let's say next year, we have a position in the Humanic project, which is funded inside of in the frame of the Marie Curie doctoral network, in which what you are going to do is the flow estimation from few probes in surgical environments, essentially to control the flow in a surgical area. Essentially what we want to do is to maintain a flow, control the flow in order to keep clean the area interested by the surgery. And this is expected to start in fall 2024. So that's all from the side.
Okay, so hello everybody. My name is Oscar Flores, and I am the director of the Computational Fluid Dynamics Lab. Okay, our activities essentially focused on understanding fundamental problems that appear in unsteady turbulent flows, typically related with the transport of either scalars or momentum, that at the end of the day is what results in the aerodynamic forces appearing in this type of problems. We are, well, this is myself. Our group has two junior researchers, Stefano Olivieri and Alberto Vela, and then at the present time we have 3 PhD students plus 1 industrial PhD student that is not in this list. Our expertise is essentially in fluid mechanics and steady aerodynamics and turbulence, and all the work that we do is essentially computational, so we are also experts in high performance computing, both developing our own solvers and also using the available tools in the industry. We work mostly on 3 lines, or most of our work can be coupled in 3 different research lines. The first one is bio-inspired aerodynamics, and that essentially has 2 different branches. One that has to do with the aerodynamics of micro air vehicles. These are very small devices of the order of a few centimeters that, in order to generate the forces that they need to fly, they essentially use flapping wings. And the reason for using flapping wings and not fixed wings or rotary wings is that these devices are so small that the viscous effects are so important that rotary wings essentially don't work well. Okay, so this would be an example of one of the simulations performed in the thesis of Cayetano, that will be presenting his overview of what is a PhD and what can you do with a PhD after it. Okay. We are also working on energy harvesting, again, microscale wind rotors to essentially power very small devices. And the idea is to inspire these type of things in how samaras fly, and samaras are these small seeds that fall from the trees and essentially fall rotating and generating some lift. We do have our second research line has to do with turbulence. Okay, the idea here is essentially turbulence is something that appears in every single flow that is important for aerospace engineering. It is responsible from most of the drag that appears on the fuselage of an airplane, for instance, and controlling skin friction is a very important and challenging challenging thing to do. We are working in two different things related with turbulence. The first one has to do with control of skin friction, and the second one is a more fundamental, more general thing and has to do with predictability and control of turbulent flows in general. And then finally, we have a line that has to do with cardiovascular fluid mechanics. This is essentially an opportunistic project that pop up because of the software that we developed to essentially work on these bio-inspired aerodynamic problems. Okay. Now, what about the future? Well, during the next year, we essentially foresee that we will be opening most likely two different PhD positions, one to work on unstable aerodynamics and another one to work in turbulence. So if any of you is interested, please email me or just talk to me after the presentation. Okay, and just to finish, we have a wide network of collaborators, both in Europe and in the US. We think that this interaction is very important, and indeed we encourage all our PhD students to have stays in different institutions. Okay, thank you for your attention.
So, good morning, everybody. My name is Andrea Cini, and now I'm presenting the lab I co-directing together with my colleague Rauno Cavallaro and my colleague Antonio Ramondo over there. And strange as it sounds, I got a PhD. So that is something that is, all of us, we got a PhD. But basically what we're going to do is our lab is called ASD Lab, is Aeroelastic and Structural Design Lab. So we are actually focused on kind of problems related to, let's say, applied research to aeronautics in general, related to two different aspects, flight physics and the structural point of view, the airframe and the interaction, actually. Manuel before was talking about multidisciplinarity, and actually this is quite important. And more, the aircraft design aspect is very, very multidisciplinary. So we need also to consider this. We are considering this kind of aspect. And as you can see, we develop different, we got research on different topics related to flight physics, aerostructure, aircraft design, MDO, manufacturing, simulation, multi-physics simulation as well, that are actually very multidisciplinary, together with, thanks to Antonio, that actually our new, member. And we can summarize everything according to what we call a vision. So, and our vision is perform research on different aspects of the development of a flying structure or a flying, vehicles, basically. So aircraft design, manufacturing, certification, performance assessment, integration of new powertrain, and the assessment of the impact on the environment. That is another important aspect that we talk in a second. And all of these kind of, methodology and design methods are aiming, that at the moment are not present. So we are developing something that is aiming at fostering the introduction of new technology in a broad sense. So everything, so cost effective, now more very, very important, environmentally friendly, and new material, advanced structure, new way of taking into account the fluid structure interaction. So all this kind of new methodology that allow us to, to improve, to increase the efficiency of the aircraft design and the new, product we are gonna develop in order to meet the tight constraint requirements that the new, the attention to the environment, the efficiency, the attention to a viable market will, expose ourselves to additional challenges and constraints. So this is quite very applied, but don't get me wrong. So being very applied means that we actually work a lot with we got a lot of collaboration with industry. So this could be a good PhD if you want to, if later on you don't want to do an academic career, but you want to work on an R&D, how it's called now, department of a company. So research is done at let's say at the university level, but also at the industry level, and synergy between two different environments is really, really crucial nowadays. In particular, when you work on cutting edge technology and something that is not, you don't have any background or you don't have any traditional, let's say, literature you can look at in order to do this kind of thing. So that means we work a lot with companies. That means a lot of European projects, a lot of industrial projects, and generally this is actually quite nice. In particular, if you are indecisive what to do, or you would like to do a research on applied things, or seeing something that is gonna fly for real. Of course, that means also benefit in terms of, let's say, possibility of statement, in terms of salary, and things like this. But don't get me wrong, we are not denying physics and mathematics, or, all the fundamental research that is quite important for, let's say, because in order to apply things and to know and apply things in an efficient way, that means actually reducing the time to market, so reducing the trial and error procedure that you generally do in order to maximize the impact and reduce the development time. You really need to know the physics of the problem and and you're actually what we call tools in the wrong way, but having a good portfolio of different, let's say, methodology, mathematical optimization algorithm, coding as well, and actually this is. So, as I said, we have several projects. We were being quite successful in the last year, opening different European and national projects and what we call service rendering, so collaboration projects funded by industry directly. So we are opening basically 4 positions in the future on different aspect. And here actually, now this is not the place to talk in details about this, but of course we got an internet site and a LinkedIn page, and feel free to contact me, Rauno or Antonio, and we will provide you with all the information. But basically we got, one of our topic is multidisciplinary design and optimization of aircraft, focus on green aviation, so sustainable aviation at the moment. And so at the moment we are considering electric high aspect ratio wing aircraft that are actually quiet and silent in order to minimize the impact around the airport and improve the quality of the, let's say, of the service and the operation of airport. And we got this more focus on design and optimization, so the development of methodology that allow you to integrate this kind of novel technology and foster that into a viable aircraft. Then we can also have airframe on the same topic, on the same project. We are more focused, this is something I'm quite familiar with, we are more focused on iframe design tool for multi-fidelity, so different level, from the conceptual design till the final design, to the detailed design of new aircraft structure, how you integrate this. Then, of course, design and optimization methodology of hydrogen. Hydrogen is seen as a source of the, let's say, for the future. Virtual certification. So this is another thing that is quite important because certifying an aircraft requires a huge amount of tests and a huge amount of time and money. And if you get something wrong there, you're going to lose a lot of, you're going to reduce time to market, you're going to lose a lot of money. So try to digitalize this kind of approach and try to minimize the amount of tests you can perform on a test pyramid is something important, and we are actually investigating now. And then, of course, what is a kind of our strong point is aerostructure and aeroelastic optimization of new generation flexible wing. We are going to maximize. We're going to integrate new, let's say, technology for green. The technology, they got a low TRL. So basically, they come with a weight penalty no matter how good you are. And you need to offset that weight penalty. And what can you do that? Optimizing your design methodology and taking the most from technology that for you are well known. Airframes, materials, flight physics, performance of the aircraft. And this is actually the reason why you need a very, very, since the beginning, a multidisciplinary approach. So that's it. Thank you very much for your attention. Any question, anything, we'll be around, or feel free to drop us an email. Thank you very much. And Gonzalo, I think the next.
Hello, good morning. My name is Gonzalo Sánchez Arriaga, and I will present the two lines of research that we have related with tethers. The first one is in the space sector. We are developing, we are working on electrodynamic tethers. And in this framework, we have different projects. The two most important ones are ETPAC, that run from 2019 to 2022, where we develop the orbit device that you can see here. This prototype with TRL equal to 4. And then we got another project also funded by the European Innovation Council that is now running. It started in September to increase the TRL up to 8. So to prepare ready to fly the orbit device. Such a device is going to be flown in 2025. A launch service agreement was signed between two partners of this initiative, of the ETPAC initiative, and we were also preselected by the European Commission for a flight opportunity. So in the last few years, we have been funded by ESA, by the European Commission, and by the Spanish government. And if you are interested in this technology, please don't hesitate to contact Manuel Sanjurjo or I, and we will see if we can offer to you a possibility of doing a PhD on this area. We are experts on software development, on tethers, on introducing new concepts like the lower function tether and the bare photovoltaic tether. And also we have experience on avionics. We have developed in collaboration with CENER the avionics of, actually in the framework of an industrial PhD in this program of this, the orbit device, so all the avionics components. The second line of research related with tethers is not in space, it is in aeronautics, and it is called airborne wind energy, so AWE, from the English word airborne wind energy, AWE. And these are machines that are able to produce electricity by using the wind energy, but they operate by using giant kites or giant drones linked to the ground by a tether. So we are able to remove the tower and reduce the cost, and also to operate at higher altitude. Nowadays, there are machines that are able to produce about 150 kilowatt in a pre-commercial state in Europe. And unfortunately, we started this research 10 years later in Spain, but we are now progressing quite fast, especially because we are now collaborating with the industry, with a company that is called City Ingenieros. And in the last few years, we have developed software in collaboration with Professor Rauno Cavallaro, who is also director of a PhD thesis on this area. We have developed software for the dynamic and control, and we have developed a test bed for the aerodynamic characterization of this type of systems. Recently, we got a space in the scientific park, and we founded the first laboratory dedicated to this area, as far as I know, in Spain. And we signed a contract with City Ingenieros to promote this technology and to prepare a first prototype in Spain for this. Actually, we have a call open, so we are looking for one PhD student that will be supervised by Professor David Santos from the Department in Electrical Engineering and myself. So if you are interested in this area, please don't hesitate to contact David or myself. Thank you.
Good morning, I'm Manuel Sanjurjo Ribo, and I'm here against my will to talk a little bit about open research lines in space sector. So we have two slides, one related to space transportation and the other to space debris. Space transportation and space debris are lines in which that it is expected to have a great development from the point of view of research in the next decade. So PhDs are welcome in these areas here or anywhere else. Here we have just a list of PhD theses that are ongoing or that were finished. So basically in space transportation, we have both guidance, navigation, and control applied to Earth orbit or beyond Earth orbit. In Earth orbit, well, David, that is present today, developed a PhD thesis on devoted to obtaining the guidance of in many different missions, both in interplanetary missions and also in Earth orbit, that allow us to obtain the optimal control law that provide us the better way of going from one orbit to other, or to one planet to other. On the other side, we have an industrial PhD also in Earth orbit in Genai, that maybe Sarah, you can comment on later on, that is developed by Giuseppe Di Pasquale, in which they explore the use of micropropulsion for a CubeSat or a small sat in order to provide this solution, this full solution of GNC in Earth orbit. I'm finishing already. Sorry. So from the point of view of Beyond Earth, nowadays the PhD thesis or Thomas Freghow that is dealing with the robust control for both rendezvous and also landing on asteroids, and also the PhD of Alfredo Escalante on using CNNs, convolutional neural networks, for producing optical navigation in both asteroids and also relative navigation in between satellites. Okay, and from the point of view of space safety, space debris, that is again is another topic that is expected to grow in the next years a lot because it is becoming a problem. In fact, one data that is one piece of data that is relevant is that in the last 7 years, the number of launches is the same as in the previous, from the 60s to 2015. So the number of launches or the number of satellites in space is increasing a lot, and this is producing a problem. Here we have a bunch of PhD theses ongoing. Many of them are close to operations. So many of them are either industrial PhD, like the one of Alejandro Cano, in collaboration with the European Space Agency, as the one of Guillermo Escribano, or also in collaboration with the Real Observatorio de la Almada, the one of Manuel Sánchez Piedra. In this line, would like to open at some point PhD in something more fundamental, that would be how stochasticity and chaos can be enhance our vision of astrodynamics for the future. So, well, thank you for the attention. Hopefully I used 3 minutes.
I think you went back to... Oh, this is actually myself. Okay. So now, as leading the area of research in aircraft operations, we basically, once the aircraft has been designed and manufactured and has to operate, there is where we step in, and we are basically started. We have 2 research lines. One is on aircraft trajectory optimization, so we wanted to optimize the trajectory in a way that we were able to somehow minimize the climatic impact of aviation, dealing with condensation trails, aviation-induced cloudiness, CO2, and other species. That's one of the things we are doing. And the other thing is we are also applying machine learning techniques to predict bad weather phenomena such as thunderstorms, wind shear, turbulence, and others, right? Also ash, and basically this is what we are doing now. I think we're missing one figure. Okay, here it is. We have been working in a bunch of projects, and we have also a lot of running projects, I would say, in collaboration with a lot of entities all over Europe, mostly, ranging from research centers to companies, and so we have a wide spectrum of activities. As for open positions, we have currently 2 open positions in the area of machine learning or artificial intelligence applied to aviation. One is related to the prediction of weather phenomena. Here we are trying to embed, well, this is a trend going on in meteorology all over the world, to blend observations together with numerical weather forecasts to enhance the quality of the forecast and tailor 13 phenomena that might be harmful for the aviation. Well, we have 2 positions that are open that we have already some 2 candidates preselected, but still, if you're interested in this type of activities, please do not hesitate to contact us. And the other position that is actually open and the submission deadline expires on Monday. So if you're interested, please talk to me today. Has to do with artificial intelligence to predict climatic hotspots derived from aviation. We're going to be using remote sensing techniques, so information from satellites, to observe contrails, linear contrails, aviation-induced cloudiness, also trying to measure the radiative forcing, the energy balance of those artificial clouds, and by these observations, combining them with numerical weather forecasts based on historical analysis, try to build a neural network architecture to predict hotspots, climatic hotspots, right? In a way that aviation stakeholders can plan trajectories or the sectorization of their space in a way that the non-CO2 aviation climatic impact is reduced. This is a hot topic today, as you might imagine, in Europe. That's all. I think I was quick. Now, Andres, I think is...
My name is Andres Marcos. I arrived at the Aerospace department at Carlos III only 2 years ago, but in any case, I always think that it's useful to know what we do, but also who we are. So I'm what is called a Beatriz Galindo Senior Investigator. The senior you can see by the hair of my hair. What I specialize is in the transfer of advanced techniques in robust control to industry. And I've been doing this for the past 25 years, and half of my career has been in industry and half in academia, covering the States, the UK, and Spain. I like everything that flies, so I have been applying this to almost all the aerospace systems except for helicopters. Control is very transversal, and when I mean about control, I don't only mean the actual controlling systems, but I also mean modeling and analysis, and the application of this to the fault-tolerant control fields, the fault detection, and the verification and validation. And I've been extremely lucky that I have been able to flight test this in pilot aircraft twice, which is something not very common in academia because it's a very expensive and highly critical system. In terms of the PhD supervision, like most of my colleagues, my idea is always to try to help achieve my students the full potential and try to help them go into the next step. As Manuel said, a PhD that goes to industry is a person that brings quite advanced knowledge and enables to impulse the activities over there. So these are the 4 students that I had in the past and I have. So Diego Navarro, Andrea Gianelli, and Pedro Simplicio was already when I was at Bristol and they graduated. And Alison Ponch here started with me at Bristol and he will finish in here at Carlos III in July. This is the work, what you see in the boxes on the right. This is an indication of how good they are, but also a little bit of how much I've been able to help them, and I'm quite proud that these are the publications that we had while doing the PhD. So some of them are stellars. Andrea and Pedro published 7 journals and 5 journals. We were able to travel quite a lot, and all of them had gotten awards or nomination. Alison, which is the current student and she's here, she got a Best PhD Poster Award when we were in the United Kingdom, and then last year she was finalist for the Best Paper at UCAS conference, which is the 2nd largest aerospace conference. But more than that, for example, what I was doing with Diego, we've been told last month that the Vega launcher actually is flying. We were working with them, and what we proposed for the control is flying one of the Vega launchers, and an adaptation of that is now the established control process and architecture that is using the Vega C. And with Alice, the same. The guidance that she proposed and got awarded at the UCAS, the reviews, the feedback from Airbus is that it's quite advanced, but it's very analytical. so it doesn't require very advanced processing. So there are chances that this will be developed in the future and implemented in their missions. So that's what I think all my colleagues also try to do, help our students to achieve. And like Manuel said, it's not only theoretical and academic. Andrea is now assistant professor in Stuttgart, but it's also going to industry. Pedro is at ESA, and Diego is a senior control expert at a small medium enterprise. In terms of the opportunities that I have, like many of my colleagues as well, we are looking at machine learning, artificial intelligence. I try to reconcile this with robust control techniques and try to apply them to the aerospace systems. We already applied to a launcher, but only to a model, one of the artificial intelligence techniques, and it's working pretty well. So I want to expand this, mostly focusing on small satellites. And we're also developing a center for satellite here at the Carlos III. And in that aspect, I'm looking at developing a EOCS verification and validation for small satellites, which is not just building the demonstrator, but there has to be a lot of theoretical developments to understand how to validate these things for control for small satellites. So these are some of the opportunities that I have. I have initiated and lead the student CubeSat at the Carlos III in September. So I'm asking all my students, and I'm also nudging my colleagues to ask their PhD students to help with this, because there are many topics. It's an actual CubeSat, has been selected by ESA for the Fly Your Satellite program. So Alison, for example, is the system engineer of the CubeSat, and I'm asking all the students to donate 10% of their time to help out these activities, which is also part of the research activities that they do. So this is all my 3 minutes.
Hi, hello everyone. My name is Mario Merino, and I think I am the last one indeed. No? So I will try to be brief.
No, we're okay.
All right.
Okay.
So, well, I'm part of the Plasmas in Space Propulsion team, okay, EP2 in Spanish. And we are a relatively large research team dedicated at the modeling, experimenting, developing, and design of space plasma thrusters, okay? Space plasma thrusters have a very exciting field of research and development that currently is taking a lot of importance in the space sector, okay, with all the developments of mega constellations and missions to the moon and beyond, all right? So it's a very exciting field to work in. I hope I can, yeah. Well, before I say any words about this, let me start by saying that we are lucky to be funded by many different projects, many of them at European level, others at national and regional level. And I think this is important to prospect PhD students, because most of our contracts, PhD contracts, are part of one of these projects. So you have the chance to be involved in a high quality European or national research project, take part in the meetings, and learn how all this world works. No? So I think it's part of the experience. Most of our activity, but not all of it, is dedicated to the modeling and simulation of the physics of plasma thrusters. Okay, so we are in touch with the very fundamental physics, like how electrons and ions move, how the electromagnetic fields evolve, and we do this with the state-of-the-art codes. Okay, so for example, here you can see one simulation that is using particle codes to simulate the flow of plasma inside a Hall effect thruster, which is a particular device that we dedicate a lot of attention to because it's one of the most important ones. We are also modeling plasma plume expansions and how the plasma interacts with the surrounding spacecraft, okay? And we are always dedicating efforts to improve our numerics, okay? So we are trying to improve, to parallelize our codes, to use new technologies and explore new algorithms, such as implicit particle codes, dual hybrid particle codes, experiments that we are doing with our PhD students that are very exciting. On the other hand, we also have simulations of more novel devices, for example, the electron-less plasma thrusters, okay? And this involves the plasma flowing magnetic fields and new designs that we are creating in our laboratory and testing them in our vacuum chamber and so on, okay? Regarding our laboratory, this is a slide where you can see some of it, okay? So we have a relatively large and unique vacuum chamber here at UC3M that we use to test our rockets, okay, our thrusters. And this is something very interesting to play with as well. As PhD student, you have access to this unique equipment, and you will be using state-of-the-art techniques to measure the plasma directly, both with probes and with optical techniques and so on. Okay, so here you can see some of the developments that we have done, such as hot thrusters, other EPTs. Some of them over there are firing and so on. Okay, so just one slide that I think it applies more or less to all the other groups as well. What are we looking for if we want to hire you? We want very good experience, academic records, sorry, both in your bachelor and your master, okay? So especially we are looking for strong profiles in mathematics and physics, okay? Because I guess that most of the PhDs have a strong requirement on this. We also look for persons that have a lot of initiative and creativity, that are responsible, and they can work both autonomously and as part of a team. In our case, for the plasma propulsion group, when we are thinking of a PhD position on modeling, this is more or less what we are looking for, okay? Someone that can program relatively well and has the skills to analyze numeric algorithms and so on. And for the experimental work, somebody that can work with the design, procurement, building, testing, and so on in an organized manner, okay? So I think there are always opportunities in this field. If you are interested, please contact us. You can find us online, and we will be happy to talk with you about prospect opportunities. All right, so that's it. Thank you, Manuel.
Thank you. Thank you.